Welcome. In this video, we'll be solving trigonometric equations involving cosecant part 2. Let's take a look at our example. Solve the equation given below for theta greater than or equal to 0 and less than 2 pi. Here we have cosecant of theta plus 3 pi over 4 is equal to the opposite of 2 square root of 3 all over 3. So let's go ahead and start by defining a new variable, alpha. So let alpha be equal to theta plus 3 pi over 4. Thus, this particular equation becomes cosecant of alpha is equal to the opposite of 2 square root of 3 all over 3. Now, rewriting this as an equivalent equation in the form 1 over a sine of alpha is equal to negative 2 root 3 over 3, we can use the unit circle. However, to do that, let's go ahead and take the reciprocal of both sides of this equation. So the reciprocal of 1 over sine of alpha is sine of alpha, and the reciprocal of negative 2 square root of 3 over 3 is 3 over negative 2 square root of 3. However, notice that the denominator here is an irrational number, so what we want to do is to multiply both numerator and denominator by the square root of 3. So this gives you that sine of alpha is equal to 3 times the square root of 3 over negative, this is a negative here, 2 times the square root of 3 times 3, which is 9. Square root of 9 is 3, which cancels with this 3, so we end up with a sine of alpha being equal to the opposite of the square root of 3 over 2. Now, recall that sine is associated with the y-coordinates. So we want any angles that have a y-coordinate equal to negative square root of 3 over 2. So let's look at our unit circle here. If we want the y's to be negative root 3 over 2, we come over here on quadrants 3 and 4, and we analyze the y-coordinates. Okay, so here's one of those y-coordinates, and if we were to reflect this particular point corresponding to that across your y-axis, we should be able to get the other one. So the angles corresponding to that are 4 pi over 3 and 5 pi over 3. So we know that alpha could be either 4 pi over 3 or 5 pi over 3. So now using those values, we need to solve for theta. So let's go ahead and recall that alpha was defined to be theta plus 3 pi over 4. So using the first value for alpha, so we can say for alpha equals 4 pi over 3, we have theta plus 3 pi over 4 is equal to 4 pi over 3. So let's go ahead and subtract the 3 pi over 4 from both sides. That will give us that theta is equal to 4 pi over 3 minus 3 pi over 4. So let's multiply this first expression by 4 over 4 so we can get the same denominator, and this one by 3 over 3. So we have 4 times 4 is 16, minus 3 times 3, which is 9. So 16 minus 9 gives you 7, obviously pi all over 12. So that's one of our solutions here. Now, keeping in mind that sine has a period of 2 pi, if you were to actually add 2 pi more, you're going to go beyond the 2 pi. So this is actually just one of the solutions. So let's use the other value for alpha to get the theta. So for alpha being equal to 5 pi over 3, we have that theta plus 3 pi over 4 is equal to 5 pi over 3. Okay, so subtracting the 3 pi over 4 from both sides, we get that theta is equal to 5 pi over 3 minus 3 pi over 4. Now let's multiply this first expression by 4 over 4 and the second one by 3 over 3 so we can get the common denominator of 12. So you have 5 times 4 is 20, and 3 times 3 is 9, so we have 20 minus 9 gives you 11, and then of course we still have the pi over the 12. So one can conclude therefore that our solutions or values for theta that will make our equation true would be either 7 pi over 12 or 11 pi over 12. So this concludes our video on solving trigonometric equations with cosecant part 2. Thank you for watching and have a wonderful day.